Hello again, ladies and gentlemen, and welcome back. We are on our second last question of the whole paper. It's question 24. Hopefully you've given it a bit of a try. A dot starts at 2019. It can move 1 unit vertically or horizontally to one of the points 2119, 1919. So it could go to the right from 2019 to 2119, or it could go the other way to 1919, or it could go up to 2020 or down to 2018. That's the way it seems to go. From there, it can move 2 units in either direction that is perpendicular to the first move. So if we had gone this way, then we could move 2 units up or 2 units down. If, for example, we'd gone down first, we could move 2 units left, 2 units right, but we couldn't move 2 units down again or 2 units back up, is what they're saying. All moves thereafter increase by 1 unit length. So, now that we've gone up by 2 units, we could go left or right by 3 units, and then maybe down by 4 units, and then left by 5 units, and maybe down by 6 units, and then maybe back by 7 units. That's the sort of thing that they're talking about here. Lots of different possibilities, because we've got 4 initial directions to go in, and then thereafter you've got 2 directions 10 times, so that's going to be what? Something like 2,048 different possibilities of what we can do. Okay, now, while I clean this up, it must be perpendicular to the direction of the move before. The dot stops after 10 moves. Which of the following locations is not possible? Okay. So we've got 5 different possibilities here. Now, as I say, there's, 2,048 or something like that, because of the 10 I spied here as I was reading ahead. So what can we do here? So there's a couple approaches that we might be tempted to try. First of all, I'd probably point out that the 2019 that we start with, this has nothing to do with it. You'll notice it's just the year. It's a 2019 contest. So what you could do is get rid of the last question. You could try starting at 0, 0. Right? And one, and then to, if you want to know which ones can't work, the same 42, 44. If we translated everything 20 units to the left and then 19 units down, we'd have, 22, 29. So if we could show that you could get to 22, 29, then from 0, 0, you could get to 42, 44 from 2019. Right? That's the idea. Not 5. That's what we would need. No, not even 5. It'd be 4. No, it's 5, yeah. I don't know what I'm talking about. Anyway, but starting at 0, 0 might help us out. The numbers might be a little easier to add. And so what we could start trying to do is we could start looking for possibilities. So after one step, what sorts of places could we be at? And so after one step, these are the only points we could possibly be at. Now, after a second step, where could we go? Well, you could go up from here. Oh, sorry, this should be 1, 0, this should be minus 1, 0. But you could go up from here to 1, 2, or you could go down to 1, minus 2. Or you could go over to 2, minus 1, or over this way to minus 2, minus 1. And you could start trying to look for patterns like that. Now, you're going to have to do a lot of calculations to sort of cover everything. Okay. Now, are we noticing any patterns, any possibilities? So one thing you might be tempted to point out is if you stuck absolute values around everything, these add up to 3. And if for the ones that we hit after 1, if you throw absolute values around all the coordinates, they add up to 1. Okay? And you might say, oh, gee, I wonder if that holds true always. Well, no. Because if I'm at 1, 2, and now I'm moving 3 coordinates this way, I'll be at -2, 2, and those add up to 4, not the 6 that you might predict. So 1, 3, 6, 10 is a very common pattern. And so if you're going to go pattern hunting like this, you're going to have a heck of a time because you're going to have to write out a lot of different possibilities, and any patterns, any properties that you think that are going to happen, you're going to have to check and make sure every point you're hitting after a certain number of steps is what happens that follows your pattern. And this is an approach, but I don't really think it's going to help us because I'm not noticing anything immediate. That was sort of the only pattern I saw was the 2, 1, 2, 1, 2, 1. But that breaks down. You're not going to get, because if you went the other way, you'd get 4, 2. If you throw absolute values around that, you get 6. But you throw absolute values around this, you get 4, and it just doesn't quite work. So another thing to work out, another way to maybe approach this question is to, instead of focusing on the points themselves, focus on how we actually get to those points. So from an initial point, 2019, I guess, in the question, we have a choice. Either we go up or down by 1 unit, or we go left or right by 1 unit. But from then on, if we choose to go up, our directions are roughly, they're sort of confined. We can't double back or keep going or anything like that. Okay? So as soon as I say I'm going up or down for my first step, I know the next one's left or right. And then I know the one after that is up or down. Okay? And so we'll always be going up or down by 1 or 3 or 5. We'll always be going left or right by even numbers. Okay? That's if we choose to go up first. So the y-coordinate changes by odd numbers, whereas the x-coordinate in this case would change by even numbers. Okay? Of course, if we started going left or right first, then the left or rights, the x-coordinates, would change by odd numbers, and the y-coordinates would change by even numbers. Okay? Now, those are two possibilities, but it gives us sort of a better approach because it takes into account that we've got this, the instructions are telling us to narrow things down a little bit. We're not having to consider all different possibilities from a single starting point, right? So this might be a little bit clearer. So now we start at 2019. After 10 steps, we're going to have gone 1 in one direction, 2 in a perpendicular direction, 3 steps in another direction. We're going to go to 20. So if we start going even, so if we start going to the top or bottom first, 9's the last odd number, and 2, 4, 6, 8, 10. The new coordinates we get will have to either be, basically you just put any plus or minuses, and those are the ones that you could, reasonably get to. Okay? So 20 and then -2 plus 4. This is a possible, if I actually work this out, so this would take me to 18, 8. So this would take me to 1824, for example. Okay, but this would involve doing what? Going down by 1, over by 2, up by 3, to the right by 4, up by 5, back that way by 6, up by 7, back by 8, down by 9, and add 10. That's sort of what we're going for here. Okay? But because of the fact that we're switching, we're changing to a perpendicular direction every single time, which is what they're saying in the question, must be perpendicular. We know that if, you're going to get all the odds here and all the evens here, and it's just a question of, did you go up or down? Did you go left or right? Are you adding or subtracting this particular even number or odd number? Okay? And so then what we can do is we can use the fact that it's a multiple choice contest and say, okay, what are my possibilities? 22, 33, 30, 20. Okay? So if I were to get to 2733, I would need to, so if I subtract off the 20 and 19, we sort of, what do I need to make with my 2s, 4s, 6s, and 8s? I would need to get 7 and 14 out of 1s, 2s, 3s, and so on. Okay? Now this brings up an interesting point. Is there a way for me to tell that, oh, I need to go 7 to the right and up by 14, which one needs to have the even numbers and the odd numbers? Well, no matter what I do to 2, 4, 6, 8, and 10, no matter how I put numbers, pluses and minuses in between them, if you add or subtract a bunch of even numbers, the result will have to be even. And with odd numbers, if I add or subtract two odd numbers, the result will be even, but then another odd will make it even, another odd will make it another odd will make it odd, and then another odd after that, so the 7 would make it even again, and then the 9 would make it odd. So with 5 odd numbers being added or subtracted in any combination, they'll have to be odd. So I know specifically I have to make the 7 out of 1, 3, 5, 7, and 9, and I have to make 14. Can I do that? And I don't actually know of a clean way to do it, but we only have so many possibilities, so we could just sort of play around with it. Now, 10 and 4 easily make 14. Can I cancel out the 2, 6, and the 8? Absolutely we can. Okay. 7 clearly makes 7, but now I've got 9, 1, 3, 5. I can use these ones here, cancel out with the 9. So there is a way to go over by 7 and up by 14 using these steps. Go down by 1, left by 2, down by 3, right by 4, down by 5, left by 6, up by 7, left by 8, up by 9, and then right by 10, and you will get there. Okay? So now we just sort of need to go and say, okay, well, A didn't work. What about B? Okay? So for B, 30, 40. What do I actually need to do? What change needs to be produced? Well, I need to add 10 from 20 and add 21 from 19. Is that possible? And notice the 21 means that's going to have the 1, 3, 5, 7, 9, 2, 4, 6, 8, and 10. So the 10's great, and then the -2 and the -8. The 4 and the 6, very easy cancel. You'll notice it's not really taking a lot of time to put this together. Now, for 7, well, sorry, not 7. For 21, we get 7, 9, and 5 would make 21. Can I get rid of 3 and 1? Not quite. So that doesn't seem to be, like, I'm not immediately seeing something. The last 3 that I've done were very easy to work with. So I might say, oh, maybe I can't do 7? Or I don't know why I keep saying 7. 21. Maybe I can't do 21. Or maybe I'm just not seeing it. Maybe they don't always jump out as easily as I'm thinking. Okay? So we could sit here, we could play around and say, well, maybe you can't do 21. Or I could say, oh, time's running out, better circle this one because I don't see a way to do it. Or we could move on to the other ones. If we can very easily show the other ones can be done, we don't really have to worry whether or not 21 could be made or not. The fact that it's a multiple choice contest could rule it out for us. So we'll table B for a moment, we'll just put it aside. 21, 21, could we do that? Well, we would need to produce a change of going right by 1 and up by 2. Right? Can you do that? And those make 12 and -12. And so just having a 1 there, that works fine. 2, 4, 6, 8, 10. 14 and -14 cancel. So it's very, very easy to sort of look at these and come up with ways to do it. I sort of make the 1 or make the 2, and then I use whatever's left over and find a way to cancel it out. Which makes me think even more that the 21 just can't be done because I wasn't able to see it right away. But, maybe I'm a big goof and I can't quite see it. So let's try 42, 21 or 42, 44. So I need to go up by right by 22 and up by, what did we say, 25. Okay, so these are bigger numbers. So 2, 4, 6, 8, 10. How can you make 22? 10 and 12 would do nicely. But 2 and 6. Right? Maybe this one, maybe it's not so easy to do this one. How about 1, 3, 5, 7, 9? Yeah, it's an arithmetic sequence, so if we just add them all up, we'll get 25 there. So we could move on, but now I've got two candidates. Maybe B could work, maybe D could work. So we might spend a little bit of time here trying to find another way to do 22, or we might go back and try and find another way to do 21. What if we overshoot it? So that's 24. If I subtract 4, I get 20, and then if I add 2, I get 22. So 22 can be done. Maybe we'll go back and try something like that for 21. But D is doable, so no. And the last one, E, 37, 37. So I need to go over by 17 and up by 18. Okay, so very, very clear which one is the odd one out and which one is the even one. So 18, add these two, and then the 6 can cancel out with the 4 and the 2. 17, let's do 7, 1, and 9. 1 and 9 make 10, and 7 makes 17. The 3 and the 5. So it looks like the odd ones are kind of hard to do. Or maybe I just need to try a little harder from like that 22. So let's overshoot. Let's say 3 and 5 and 9 is 19. Subtract 1 would be 18, add 5. No, that's not going to work. 5, 7, and 9 is 21, and if you subtract 4, we get 17. So E is out. So it must be that B just doesn't work, and so B should be our answer. But did we try hard enough? Okay. Well, we could try overshooting it a little bit. So 9, 7, 5. If I add on 1, that's going to be, what, 22? Subtracting 3 takes too much away from it. And if I add on 3, that'll be 24. Subtracting 1 brings me down to 23. So it looks like this sort of overshoot method doesn't work. And so we could try and think of a more concrete way to do it. If you want to, you can just move on. We've got B as our answer. But let's think about it for a moment. If we add them all up, we get 25. Now to get 24, I need to change the sign on at least one of these. Okay. If I make the 1 minus, I get 23. So that's not enough. And if I subtract a 3 again, then we lose, we're down to 17. So that's not the case. So subtracting 1 isn't going to work. What if I subtracted 3? Well, that would bring me down to 19. That's too low. And subtracting anything like 5 or 7 or 9 instead of the 3, that's just going to take us even further below. So you just sort of realize by exhaustion that, you can't do 21. Okay? Now, maybe if that pattern technique that we had done at the start, if we'd actually bothered to work it all out, maybe we could have seen a more ironclad way, a formula, or a way of combining the numbers easily to tell, maybe it's this number plus twice this number minus 10 or something like that to see the answer. But working it out this way, it wasn't so bad. It didn't take too long. If you had a different way of approaching it, or if you managed to get that pattern to work, by all means let me know down below. But I think we're going to move on to question 21. So thank you guys so much for watching. Feel free to like the video or subscribe if you want to be kept up to date on this or any other contests. But other than that, I'm just going to see you guys for the next question 25, as we finish off our grade 7 Gauss.